You've tuned into Nocturnal Historian, where we ponder the strange, the vast, and the deeply buried stories of our world. Tonight, let's not gaze at the stars or wonder about cosmic beginnings. Instead, we'll turn our attention inward to the ground beneath our feet and ask a question that's both simple and unsettling. What if we're not the first? Not the first to think, to build, or to dream? Imagine a time long before the pyramids, satellites, and late-night documentaries. What if another intelligent civilization once thrived here on Earth, rose to a complex state, and then simply disappeared? I'm not referring to fantastical tales of Atlantis or lost alien outposts. I mean a genuine biological, homegrown civilization, perhaps intelligent in ways we can't even comprehend, that lived and died so long ago the planet itself may have completely forgotten. While this might sound like a plot from a science fiction movie, it's also a legitimate scientific inquiry, one that has been quietly debated in geology labs and cosmology conferences for many years. The core idea isn't that we'll find ancient skyscrapers beneath the Antarctic ice or buried in ancient coal seams. The concept is far more subtle. The question is this: if an advanced civilization had existed millions of years ago, could we even detect it? Would any evidence survive the slow, relentless geological processes of the Earth? Or would everything, cities, tools, language, even bones, be recycled back into rock and soil, now completely indistinguishable from a natural world? Before we begin our exploration of what might be hidden beneath the layers of time, I'd love to know where in the world you are and what time it is for you right now. It's ironic, isn't it? Our topic is ancient civilizations. Yet here we are, separated by countless miles and mere seconds, quietly sharing this very moment. No matter where or when you are, I'm genuinely glad you're here. If this kind of slow burn, thought-provoking question is what you're looking for, please consider liking this video or subscribing to the channel. It helps this quiet little signal reach other curious minds. Of course, there's no pressure, just a simple invitation, like a faint trail of footprints that might, if we look closely, lead somewhere unexpected. So, settle in, perhaps lie back if you can, and let your thoughts drift to the ponderous pace of plate tectonics. We are about to take a long look backward, not through the annals of human history, but through the immense crust, silence, and heat of deep time itself. Because before we can ask whether someone came before us, we have to grasp just how much time we're truly dealing with and how good this planet is at wiping the slate clean. When we talk about ancient history, we typically mean a few thousand years. The pharaohs of Egypt, the builders of Stonehenge, the earliest known scripts etched into clay tablets. Even when we extend our reach to the dawn of human civilization, we're still only going back about 10 or 12,000 years. In geological terms, that's nothing more than a fleeting blink. It's closer to our present moment than almost anything else that has ever occurred on this planet. Yet to us, it already feels like a distant past, a time period already sufficient to fill countless libraries with mystery, debate, and speculation. But the Earth is old, incredibly, profoundly old. Not just millions of years old, billions, around 4.5 billion years, give or take a few hundred million. For the vast majority of that time, there were no humans. There weren't even mammals for most of it, and for much of that history, there was no life on land at all. Life spent a very long time swimming, waiting, or evolving in microscopic obscurity. And yet, despite how empty that sounds, this was when the majority of Earth's story was written, layer by layer, rock by rock, in forms that speak very slowly and forget very quickly. The planet doesn't keep a perfect diary. It doesn't preserve everything equally. With decays, metal rusts, bones dissolve, and time doesn't simply pass. It actively buries, melts, crushes, shifts, and erases. Mountains rise and crumble. Oceans open and close. Entire continents drift, collide, and break apart. Every few hundred million years, the face of the world changes completely. And when you see it this way, it's not that evidence simply gets lost. It's that anything at all surviving for more than a few million years is already an extraordinary event. So let's imagine, purely as a thought experiment, what if, say, 100 million years ago, long after the age of the dinosaurs began, but long before it ended, an intelligent species evolved. Perhaps it was upright, or maybe not. Maybe it was land-based, or maybe aquatic. Perhaps it didn't build with stone or metal at all. Maybe it never needed to. Perhaps it had a form of technology we wouldn't even recognize. Maybe it flourished for a while, developed something we might call a culture or society, and then something happened. A global shift, a catastrophe, or simply the slow march of time. And it vanished. And now we arrive millions of years later, asking whether we'd even know if it had been here. Because here's the difficult truth. We are not as permanent as we like to believe. Our skyscrapers, our highways, our libraries, and our satellites are not built to survive geological time. Leave a modern city alone for just a few centuries, and nature begins to reclaim it. A few thousand years later, it's already difficult to tell what was once there. But a few million years? Erosion, tectonics, subduction. By then, the entire surface has changed. What was land might now be the seafloor. What was a mountain might be a pile of rubble. And most of our traces would be completely gone. This isn't just science fiction. It's grounded in what we understand from geology and archaeology. Evidence of even recent prehistoric human activity is incredibly rare. Not because humans weren't active, but because Earth is an incredibly efficient recycler. Consider the fossil record. It is spotty at best, not because life wasn't abundant, but because the conditions for fossilization are very specific. Most organisms that die are never fossilized. They decompose. They get eaten. They dissolve. To become a fossil, you need a rapid burial, mineral replacement, and protection from erosion. And then you need to be incredibly lucky for that rock to survive, get exposed, and be found by someone. Multiply that challenge by tens of millions of years, and you begin to grasp the sheer scale of the problem. And it's not just bones. Buildings, artifacts, tools, even those made of metal, don't last forever. Most metals corrode. Most plastics break down, especially when exposed to sunlight or buried underground. Even concrete, if left unprotected, eventually crumbles to dust. So, if a civilization had existed in the distant past, especially one that didn't leave behind vast quantities of stone structures, we might never know it was there. You might be wondering, has anyone ever seriously considered this? And the answer is yes. In 2018, two scientists, Gavin Schmidt and Adam Frank, published a paper exploring this very idea. They weren't arguing that such a civilization actually existed. Instead, they were asking how we would even begin to detect it if it had. They called it the Silurian Hypothesis, named with a bit of a wink after a fictional race of intelligent reptiles from an old British sci-fi show. Their true question was more methodological. What kind of traces would an industrial civilization leave in a geologic record after millions of years? And could those traces already exist, perhaps misinterpreted as something else? They focus on markers, chemical signatures, strange anomalies, things like carbon isotope ratios, unusual concentrations of rare elements, or synthetic molecules that don't occur naturally. In essence, they were thinking like detectives who can't find a body, a weapon, or a witness, but are hoping the wallpaper might still tell a story. And in doing so, they brought up an uncomfortable possibility. Maybe the absence of evidence isn't evidence of absence. Maybe it's just what the planet looks like when it resets the surface every few 100 million years. Because civilizations don't just vanish cleanly. They leave behind a lot of waste. Energy use, agriculture, mining, and manufacturing. All of these leave fingerprints. But those fingerprints fade. And if a previous civilization had gone through its own industrial age or something comparable, will we still see the effects in climate records, sediment cores, or the composition of ancient rocks? Maybe, maybe not. Even now, our own impact on the planet is being written into the geological record. This is sometimes called the Anthropocene, the proposed name for a new geological epoch defined by human influence. Plastic in the oceans, concrete in the soil, nitrogen in the atmosphere, radioactive isotopes from nuclear tests. If future scientists, whoever or whatever they are, were to dig into our present, they might find these markers. The question is, how long would those markers last? And how visible would they be if millions of years passed before anyone looked? This isn't just idle speculation. Thinking this way helps scientists test the limits of their own methods. It's about understanding not just what we find, but what we are likely to miss. The geological record is full of gaps. Some periods are well preserved, while others are almost entirely erased. Erosion can remove layers of sediment that took millions of years to build. Tectonic activity can fold, fault, and bury entire regions. And then there's the ocean, which covers more than 70% of the planet's surface and hides countless secrets beneath miles of water and sediment. Most of the Earth's surface is geologically young. That is, it's been resurfaced or altered within the last few 100 million years. Even the ocean floor gets recycled through a process called subduction. Old sea floor is pushed under continental plates and melted back into the mantle. That means if an ancient civilization had built anything near a coast or on an island, or even worse, in a now submerged region, those traces might be long gone. And yet, here we are, building, recording, and observing. We often wonder if we are alone in the universe, but we rarely ask if we have ever truly been alone on this planet. Maybe the past was quieter than we think, or perhaps we've just lost the ability to hear it. We'll pick that up shortly. As we look more closely at what could survive, what couldn't, and whether we've already stumbled across traces without realizing it, there's more to this story, more layers, both literal and scientific, and we'll keep moving gently through them one at a time. All right, let's slow down and ask something foundational. Before we go looking for lost civilizations, we should probably decide what we're even looking for. What exactly is a civilization? And what would make one count, scientifically speaking? In everyday conversations, we tend to think of civilization as a sort of upgraded society. Cities, writing, governments, maybe a distinctive skyline. But that's a very narrow, very modern viewpoint. Even in human history, civilizations have looked wildly different. Some built vast cities with monuments and extensive road systems. Others left almost nothing behind but a language and a particular way of using the land. And yet we would still call them civilizations. In archaeology and anthropology, the definition gets a bit more specific. Civilizations are usually identified by a set of shared traits: urban centers, specialized labor, centralized authority or governance, surplus agriculture, organized religion, social stratification, the development of writing or symbolic communication, and long-distance trade. Those are the big ones. But not all civilizations check all the boxes, and some do it in ways we might not expect. So when we discuss the possibility of forgotten or deeply ancient civilization, we need to broaden our thinking. We're not necessarily looking for giant pyramids or buried computer chips. We're looking for evidence of complexity, social, technological, or ecological things that don't happen by accident. Things that suggest a group of beings organized themselves on a massive scale over time for purposes that went beyond mere survival. It's helpful to think about civilization less as a finish line and more as a spectrum. Somewhere between isolated survival and planetary engineering, there's a lot of room, a culture of tool users that created structures or systems that lasted beyond an individual's lifespan, a species that learned to store knowledge, pass it on, and deliberately modify its environment. That might not sound like much, But in evolutionary terms, it's monumental. And if it happened more than once on this planet or anywhere else, it's a concept worth taking seriously. Let's look at an example closer to home. Consider the ancient city of Catalhoyuk in modern-day Turkey. It's about 9,000 years old. No streets, no monuments, no written language, just densely packed homes built side by side with no doors. People entered through the roofs. Yet, it's considered one of the earliest known urban settlements. Because what truly matters isn't the skyline, it's the pattern. Coordinated building, long-term settlement, shared rituals, food production, burial customs. Even without grand architecture, it's a clear sign of collective behavior over generations. Go back even further, and the clues become more subtle. The earliest evidence of symbolic thinking in humans comes from tools, pigments, and carvings, things that imply planning, memory, and perhaps even belief. Not technology in the modern sense, but still technological within their own context. Evidence that minds were working in abstract ways. So now, imagine a civilization that existed not 10,000 years ago, but 10 million or even 100 million. What would we expect to find? It depends heavily on what they were like. If they built with organic materials, wood, plant fiber, animal products, those materials wouldn't last. If they buried their dead with rituals but not with durable artifacts, we might find bones but completely miss the meaning. And if they never developed writing or used a form we don't recognize as writing, their stories might be lost forever. Worse still, if they didn't live on land or spent most of their lives in environments that don't preserve fossils well, our chances of detecting them shrink even further. If a civilization arose in a rainforest, on a coastline, or in a swamp, most of its remains will be gone within a few centuries, let alone millions of years. It's not a matter of hiding. It's a matter of time. We also have to be careful not to project too much of ourselves onto them. We're used to seeing intelligence in the form we exhibit, language, tools, cities, and now digital technology. But intelligence doesn't have to look like us. A civilization might not be industrial at all. It might organize its society in ways that don't leave big material traces. It might communicate chemically or visually or through forms of behavior for which we don't even have words. And that brings up a strange problem. Would we even recognize it as a civilization? Think of a termite mound. To us, it's just a nest, a large pile of dirt. But in terms of engineering, it's a marvel. It has internal climate control, sophisticated air circulation, and resource storage. Termites build collectively and even farm fungus. Their colony behaves almost like a single organism. If we didn't know what we were looking at, we might mistake it for a natural structure. Now, scale that up by a factor of 1,000 or bury it for a few million years, and even that trace might disappear. So when we think about lost civilizations, we need to think like archaeologists and like biologists. We're not just looking for ruins. We're looking for patterns, anomalies, disruptions, unexpected concentrations of minerals, changes in sediment that don't match known processes, or strange isotope ratios, things that might suggest someone or something was here doing something unusual. There's also the question of duration. How long would a civilization have to exist to leave a lasting mark? Not very long, geologically speaking. Humans have transformed the entire planet in just a few hundred years of industrial activity. In terms of sediment, that's barely a dusting, but the chemical impact is measurable. Greenhouse gases, synthetic compounds, nuclear isotopes. Even if we vanished tomorrow, some of those changes would still be detectable for tens of thousands, maybe millions of years. So maybe the better question isn't whether a previous civilization existed, but whether we're even asking the right questions to detect it. We look for signs that make sense to us, fossils, ruins, tools. But what if the signs are stranger, smaller, or in places we haven't thought to look? We'll continue. Because to fully answer this question, We need to look at how the Earth behaves over long spans of time, not just centuries or millennia, but entire epochs. And that means looking at the forces that erase what stays, what fades, and why. If you want to hide something forever, you don't need to bury it deep or burn it up. You just need to leave it on the surface of the Earth and wait, not for days or decades, but for long enough for geology to do its work. Because the Earth is not still. It breathes, it shifts, it consumes, and almost everything built on top of it eventually disappears. We don't notice this much in our day-to-day lives. We tend to think of landscapes as permanent. Mountains seem eternal. Rivers always seem to be in the same place. Cities feel like they have always been where they are. But geologists see something else entirely. They see motion in what looks solid. Over enough time, even the hardest rock flows, bends, or breaks. Even the tallest peaks crumble. The surface of the Earth is constantly being reworked. And that means anything resting on that surface is, by default, temporary. Start with weathering. Rain, wind, frost, and heat all slowly chip away at anything exposed. Cliffs erode grain by grain. Roots push through concrete. Metals oxidize. Organic matter rots. It doesn't take long for buildings to become ruins, and then for those ruins to become barely distinguishable piles of debris. And if those remains aren't preserved under special conditions, rapid burial, an arid climate, or a deep freeze, they are as good as gone in geological terms. Then there's sedimentation. Soil, sand, dust, ash. All of it builds up over time, layer by layer, burying whatever is underneath. Sometimes this helps preserve artifacts or fossils, but can also crush and distort them. Layers compress into rock. Organic materials get broken down or replaced by minerals. And after a few million years, that buried city or skeleton might be a vague imprint in a chunk of limestone, if it's there at all. Tectonic activity is another key player. The Earth's outer shell isn't one solid surface. It's a patchwork of plates that float on a slow-moving sea of molten rock. These plates collide, pull apart, and slide past each other. When they do, they create earthquakes, raise mountains, open new seafloors, and drag old ones back into the mantle. This last process, subduction, is especially important. It means that entire sections of the ocean floor are gradually pulled under continents and recycled. Whatever was on them, sediment, fossils, cities, melts and becomes part of the Earth's interior, not buried but erased. The average age of the ocean floor is only about 200 million years, which sounds old until you remember the Earth is over 4.5 billion years old. That means most of the planet's seafloor has been replaced many times over. If an ancient civilization had lived near the coast or on islands, there's a very real chance their traces would now be at the bottom of a tectonic plate, slowly turning into magma. Continental surfaces last longer, but even they don't keep a perfect record. Erosion wears them down. Glaciers scrape them clean. Volcanic eruptions coat them in ash and lava. Forests come and go. Deserts migrate. Rivers change course. Even massive impact craters can fade over time. What looks permanent from our human perspective is often just the current state of something in constant motion. The Grand Canyon is often held up as a great geological archive, layers of sedimentary rock, stacked like the pages of a book. But that book is missing chapters. There are gaps where layers were never deposited or were removed later by erosion. These gaps are called unconformities, and they are a powerful reminder that the geological record isn't complete. It's a patchwork stitched together from what happened to survive, and survival is rare. The fossil record, which we use to understand ancient life, is incredibly incomplete. Most organisms don't fossilize, and even those that do are only found when erosion or excavation exposes them. It's not that fossils are common, and we just haven't looked everywhere. It's that fossils are incredibly rare, and most are gone for good. If that's true for bones, literal pieces of living organisms, it's even more true for cultural artifacts, tools, buildings, inscriptions, technology. Even with humans, whose artifacts are only tens of thousands of years old, we often find mere fragments: a flint knife, a piece of pottery, a post hole in ancient soil. Archaeologists reconstruct entire societies from scraps because that's usually all that remains. So when we ask whether another civilization could have existed millions of years ago, the burden of proof is enormous. It's not just that we haven't found their ruins. It's that the odds of anything surviving that long are already vanishingly small. And even if something did survive, it would have to be in a place that hasn't been subducted, eroded, buried too deeply, or completely changed. Consider how we look for impact craters. Large asteroid impacts leave scars, craters hundreds of kilometers across. But some of these craters are difficult to see because over time they're eroded, buried, or deformed. Some we only detect through gravity anomalies or subtle changes in rock composition. Now, imagine trying to find something much smaller than a crater, a city, a factory, a carved monument. Unless it was preserved in a perfect geological niche, it would be extremely difficult to detect. And preservation alone isn't enough. Someone has to be looking in the right place at the right time with the right tools and the right questions. Most paleontological digs aren't looking for signs of intelligence. They're looking for species, bones, and ecosystems. They examine sediment layers for traces of life and extinction events, not for signs of roads or buildings. And if an object doesn't look artificial, if it isn't shaped like a tool or clearly manufactured, it might not be recognized for what it is. Even when we do find something unusual, the first assumption isn't that it's from a civilization. It's a natural process, and that's a reasonable scientific bias. Nature is capable of producing very complex, structured patterns: crystals, geodes, erosion features, mineral veins. Without context, it's hard to tell what is natural and what is artificial. A perfect sphere might be a decorative object, or it might be a simple concretion, without surrounding evidence. It's just a curiosity. This is part of why the Silurian Hypothesis focuses on indirect evidence. Rather than looking for buildings or tools, it asks whether an earlier civilization might have altered the Earth's chemistry or climate in a detectable way. In other words, not what they built, but what impact they had. Even that is hard to trace because natural events can produce similar changes. A massive volcanic eruption, a large methane release, or a mass extinction can all leave chemical fingerprints that can look similar to industrial activity. So the challenge isn't just finding the evidence, it's interpreting it. And that requires humility. Not because the idea is likely, but because ruling out completely requires more certainty than the planet tends to allow. We tend to think of history as a straight line with a clear beginning and a clear end. But the geological record doesn't care about lines. It cares about pressure, heat, erosion, and deposition. It rewrites itself constantly. And that means most of what happened on Earth, most of what was ever built, spoken, thought, or dreamed, is gone. Not hidden, just undone. But we're not done, either. If the Earth is so good at erasing, then we need to understand what resists that eraser, what can last, not just for centuries, but for millions of years. So, next, we'll look at the kind of evidence that might endure and how we can recognize them. Not fossils, not buildings, but something subtler, something more chemical than architectural, and more stubborn than stone. When people hear the word fossil, they often picture a perfectly preserved dinosaur skeleton laid out in a museum, bones arranged just so, as if the creature simply lay down and became stone. But real fossils rarely look like that. They are fragmented, partial, and compressed. They require immense luck, very specific environmental conditions, and a vast amount of time. Even under the best circumstances, fossilization is an exception, not the rule. And the story it tells is often incomplete, selective, and silent on many important details. The fossil record is one of the best tools we have for understanding ancient life, but it doesn't give us a complete picture. It's like trying to reconstruct an entire movie from just a few still frames, some torn film, and a few scattered subtitles. For every species we've identified in the fossil record, there are likely dozens or hundreds that have left no trace at all. Some never fossilized. Some did, but their remains were destroyed. Others still lie buried in places we haven't explored yet. So, when we talk about ancient civilizations, especially hypothetical ones, it's important to keep in mind that we're already working with a record full of blind spots. Fossilization depends on a combination of factors: how and where an organism dies, what kind of sediment it's buried in, how fast that sediment accumulates, whether scavengers get to body, whether the site is geologically stable, and whether erosion or tectonic activity later exposes a fossil without destroying it. That's a lot of conditions. The odds are stacked against preservation from the very start. And for most of Earth's history, the places where life thrived, coasts, floodplains, forests, weren't ideal for fossilization. They were too active, too wet, too exposed. Now, imagine trying to preserve not just bones, but artifacts, tools, structures, and infrastructure, things that don't even begin with the durability of bone or shell. The odds drop even further. Even stone tools, which are relatively resilient, can be hard to date and identify if they're found out of context. A chipped rock might be a tool, or it might just be a chipped rock. Without patterns of use or associated artifacts, it's difficult to say. And most technological materials don't survive the way bone does. Metal corrodes, fabric decomposes, and plastic breaks down unless it's buried in an oxygen-free environment. This means that even for our own ancestors, the record is incomplete. Take Homo erectus, a species that existed for nearly 2 million years. We have tools, bones, and some evidence of fire use, but much of what they did is unknown. They traveled widely, adapted to different climates, and likely had forms of communication. But we don't know what they believed, how they organized themselves, or what they dreamed. Not because they didn't leave signs, but because those signs didn't survive. When we dig into fossil record, we're digging into the survivors, the lucky ones, the ones whose remains happen to fall in the right spot under the right sediment, away from too much pressure or heat. That's why periods of mass extinction leave such distinct layers. There's often a sudden die-off, a lot of material getting buried quickly, and less time for decay to erase the evidence. The layers where we find the most fossils are often moments of crisis, not moments of civilization. So, if we were looking for evidence of a past intelligent species, we might only find them if they lived near one of these rare, fossil-friendly zones and were then caught in a preservation-friendly disaster. It's a narrow window, and that's assuming they left bodies at all. Intelligent life, especially if it developed advanced technology, might have disposed of its dead in ways that don't promote fossilization. Cremation, sky burials, sea burials, or decomposition in designated places. And beyond that, there's a more subtle issue. What if a civilization advanced to the point where it stopped leaving biological remains entirely? What if it transferred its thinking into artificial systems, or evolved into something less physical, more distributed, and less organic? We don't know if that's possible. But if it were, the fossil record wouldn't just be silent. It would be irrelevant. Even now, most of the matter involved in our day-to-day lives is synthetic, non-organic, or so processed that it wouldn't register as natural to someone studying our remains. Millions of years from now, a future geologist might find layers of strange polymers, rare earth elements in metal alloys, and not recognize them as remnants of civilization, especially if the context is missing. Imagine finding a thin layer of titanium dust in a 100-million-year-old sediment core. It might raise questions, or it might be dismissed as a random anomaly. Interpretation is as important as observation. And that brings up something often overlooked in discussions of the fossil record: bias. Not just in what gets preserved, but in how we analyze it. We tend to see what we expect to see. And the idea that a civilization might have come and gone millions of years ago doesn't fit comfortably into most scientific frameworks. So unless the evidence is overwhelming, it's likely to be classified as natural variation or an unexplained anomaly, not because of negligence, but because that's how science works. It prefers the simplest explanation that fits the evidence. And civilizations, especially ancient vanished ones, are not simple explanations. This is why the fossil record doesn't tell us everything. It tells us what the planet allowed to be preserved. It tells us what we happen to find. It tells us what we are able and willing to interpret. But it certainly doesn't tell us the full story of life on Earth. And it definitely doesn't tell us everything about intelligence. Still, we have other tools. Not just bones and artifacts, but signals, signs in the soil, in the atmosphere, and in the chemistry of rocks. Traces left not by bodies, but by processes. And that's where we'll go next, into the kind of evidence that don't rely on fossilization, that aren't about bones at all, but about what happens when something begins to change the very planet lives on. When intelligence leaves a fingerprint not through tools or cities, but through chemistry. In 2018, a pair of scientists named Gavin Schmidt and Adam Frank posed a question that managed to be both wildly speculative and scientifically grounded. They asked, if an industrial civilization had existed millions of years before humans, would we be able to detect it in the geological record? They weren't arguing that such a civilization actually existed. Instead, they were exploring how science would even begin to look for one. And in doing so, they gave this question a name: the Silurian Hypothesis. The name is a nod to a British science fiction show where intelligent reptiles, the Silurians, had once ruled the Earth before humans. But the hypothesis itself isn't about science fiction. It's about testing the limits of geology and paleoclimatology. It's about asking whether our own impact on the planet is unique or if it could resemble something much older, hidden deep within the Earth's layers. The premise is simple. If an industrial civilization like ours had developed, say 50 or 100 million years ago, and then vanished, what traces would it leave? And would those traces survive the erosion, burial, and tectonic upheaval that occurs over that kind of time span? The scientists began with what we already know, that our own civilization is leaving geological fingerprints. We're changing the composition of the atmosphere, the soil, and the oceans.